My next step is going to be to drill and bore the two holes that are going to take the pistons. Now, my original bore in the top of the block to take the cam was 28.3 millimeters deep. I intend on using some 12 millimeter brass, so I must come up with a little bit of clearance, half the diameter of that, which would be 6 mil, give it half a mil of clearance, 6.5 mil. So as you can see, if I drill a hole 21.8, which is 6.5 mil less than 28.3 from the top face, and then central about of my 32 mil wide dovetails, so 16 mil on the center line of the dovetails, through into that central bore. I'll bore out some sort of nominal size 12 mil and then machine the pistons to suit the bores with a nice fit with an O-ring afterwards. So next step I've done is to center pop my block. I've marked it out. Oops, hang on, try not to drop it. Where are we? Okay, so I've center punched a center pop in my block. As I said, 21.8 down from the top, and central about 16 mil in. Double checked it, come from both sides with the calipers to check the center pop, and it's on the center line of the block. So to locate the center pop, I use my magnifying glass. I got a magnifying glass here that's got LEDs on it. Made of steel of some description, quite heavy, weighs about a pound. Had it quite some time, used it lots, never put any spare batteries in it. £7 in Lidl's. Can't fault it. Every now and again something good comes up in Lidl's. But yeah, I've used it quite a lot just for picking up fine lines and looking at fine details. So yeah, good old Lidl's. So I've set my block up in the forejaw. It's not clocked up yet. You can see it's a bit awkward to hold, but it's in there. And I put a piece of cardboard behind each one of the jaws, just to stop my jaws marking the block and digging in there. It's quite a new chuck, and the edges of the chuck jaws are quite sharp and will dig into this block. I've set my clock up in the original quick change tool post, and using this pin, which is basically a piece of ground rod, it's a piece of 01 silver steel ground. One end has a center drilled hole in it, exactly on center. It was clocked up in the forejaw to drill it, and the other end has a turned point on it, which again is exactly on center of the bar. So by placing the one end of this bar, the pointy end, in the center popped hole in the block, and the other end in a live center in my tailstock. My tailstock's running really, really good. So we're just going to center drill this hole. I'm only actually running at 204 RPM, which is very slow, way too slow for this center drill really. However, the amount of balance offset in this block, because it's obviously it's a weirdly shaped block, and the hole is not about the center of the mass. If I spin it up any faster than it's going, I get really bad vibration on my lathe, and my whole bench starts to shake and rumble. So just to keep it in balance, I just run nice and slow. Way too slow for the center drill, as I say, but as long as I take it gently, not a problem. So I'm going to change of plan. I have a 12 mil reamer. Plan is center drill, step it out to like 11.8, something like that, and then run a 12 mil reamer down the hole. Break the edge on the outside surface, probably do that with a little needle file, and that will be one board done. Second board will just be a complete repeat operation, setting it up in the forejaw and away to go. That's one done. Open it up to a bigger drill next. Nice and gentle through final process of the 12mm reamer. At these very low speeds, there's not a huge amount of torque in the lathe. It comes a problem when you've got very large diameters and you're trying to part off, because you want to run at the appropriate speed for the cutting tool. And at the lower speeds, you know, sort of less than, well, certainly less than 100, or, you know, anywhere from sort of 200 down, it does lose quite a bit of torque. So when you're going at very low speeds, you do have to be very gentle with your feed rate and, you know, the amount of pressure you're putting on the cut. Just one of the little small drawbacks of the lathe, but doesn't on a daily basis become a nuisance at all. At the end of the day, it's a small lathe. It's not designed for, you know, it will swing 180mm diameter, but it's, you know, 180 as it is, you know, it's a WM 188, but it will swing 180. But, you know, if you wanted to part off 180, you'd be pushing it with your RPMs and what have you. Okay, that is first of the two 12mm holes reamed. Well, that's the two piston holes done in the block. One on the front face, one on the top, both drilled and reamed to 12mm. Let's have a little look in the bore. I wonder if we can get in there and pick that up. And as you can see, in fact, a little bit of an error on this one. It's just scratching the bottom surface, but that's no problem. And that one, yeah, probably 10 thou, 15 thou, something like that from the bottom edge. Yeah, a bit of a mystery that. Must have been a little bit out on my centre pop. But the piston itself doesn't actually intrude into the cylinder. That'll become apparent later on, so no worries with it fouling on that bottom face. Okay. The next job is going to be to make the clamp bolt that clamps the tool post onto the compound slide. Okay, so looking at the drawing or sketch that I've done earlier on, the depth of the 18mm bore in the top of the block is 36.3mm. So what I'm looking at is my clamp bolt is going to have an M10 thread up the middle. It's going to be 17.9 diameter, which will fit in the 18mm hole. I'm going to allow 10mm for the cam lock gap on the top of it. So that puts me up to 46.3. And the head's going to be approximately 12mm thick. So my total is going to be 36.3, 46.3, 48.3, 58.3mm overall length. The maximum diameter there is 22. And I've got a piece of inch diameter bar, a piece of EN8, which is fairly tough, set up in the lathe, and I'm going to part it off. Now, the bore through the spindle of my lathe won't take any more than 20mm. So I can't put a piece of bar in the chuck sticking out 60 odd mil, 62, something like that, and part it off in fresh air with a centre in it. So the only other option I would have had would be, I haven't got a bandsaw or anything like that. I do have a cutting disc and a grinder. I could have done it that way, but that's all a bit noisy. But why bother with that when you've got a lathe and a parting tool? So I thought the other alternative would be to set the bar up, run it in a fixed steady on the far side of the carriage, hold the bar, set the fixed steady up, part it off. Why not? Got a lathe, part it off. Less noisy, less hassle, no problems. Obviously with this setup I'm not going to part it off completely, because that will leave the scrap piece of bar flailing about in mid-air and might have a crash, all sorts. So I'll probably part it off to within about, I don't know, I'll leave about an 8mm diameter, and I should be able to hacksaw that off in seconds. parting, everything sharp, everything lined up. Keep the pressure on, don't be afraid of it. This isn't the ideal setup. I can get a bit of chatter out the travelling steady. I'll fix steady. Using a bit of cutting fluid. And it's coming off the tree. I'll give you a close up of that. Let's give you a close up. Not sure how successful this is going to be. Pressure on. Don't break the net, just keep the pressure on it. As you can see, the WARCO lathe, inch bar, starting all set up correctly. Even though I'm running in a steady way out here, it's chewing it. And it's the piece of EN8. And it's not the softest stuff in the world. That shouldn't be a problem. Now, as I said, I'm not going to cut very well. I've got one hand on the camera, one hand on the cross slide wheel. I haven't got a spare hand to put some gloop in there. Here we go. Going down to about 8 mil, something like that. Just going a bit further. I'm trying to watch the cut angle at the same time. That's about 6 mil. And that'll take me moments to hacksaw off. But how long would it have taken me to hacksaw through an inch bar? Only a couple of minutes. But why have a dog and bark yourself? While I'm in the mood for parting off, I've got a piece of, I think it's 1 3/4 bar here. That's going to be a bit of a challenge for the parting tool. And to make the cam, again it's a piece of EN8, to make the cam I'm going to need a piece about 40 mil long. I'm certainly not going to hacksaw it off at 1 3/4. So I've set it up in a 3-jaw again, running nice flat end. This end was wobbling about all over the place, so I've just tapped it in through and clocked it up, just, you know, within a couple of thud. And I'm going to centre drill very carefully, centre drill the end of it, because there's a lot of weight hanging out there and it's only just holding in the 3-jaw shut. I'm just tickling it with a centre drill in the end. Not doing anything untoward, not giving it any welly at all. There's a fella I follow on YouTube, great guy, great channel, Double Boost, John Mills, and he's got a saying which comes up quite a lot, which is that a centre drill has got one ambition in life. And he's spot on, and that ambition in life is that it wants to snap off in the hole. You can't give them enough respect, centre drills. They do a great job. But when they snap off in the hole, you get all sorts of grief. So when centre drilling, keep backing off, keep cleaning it up, and away to go.